Let's walk through Selenium automation testing framework's general knowledge. Selenium frameworks are based on Selenium itself application and potential involvement of three major languages: Java, Python, C#. Such approach is based on DOM or Document Object Model, cross-browsers web drivers, and potential application involvement of Page Object Model approach. Selenium Test Automation Framework. Selenium is an open source suite of automation testing tools and libraries dedicated for rapid functional testing automation across most popular and up-to-date web browsers in order to eliminate repetitive regular approach testing that consumes time and effort. Selenium today totally conforms with the Agile approach and DevOps CI/CD as continuous integration, delivery, and production deployment principles to endorse the daily business operations seamless delivery workflow. Apache Maven is a software project automation management tool that is based on pom.xml, which stands for Project Object Model, and primarily used for Java projects for build, dependency, and documentation. Let's take a look at basic steps for Selenium-based test automation framework structure. First of all, you need to select programming language and IDE, integrated development environment. For example, Java and Eclipse. In this case, we're going to be talking about Java and Eclipse, but you can do it same with Python and PyCharm, for example. Secondly, select appropriate project frameworks type, like Selenium WebDriver and TestNG. Download, install, and create Apache Maven project and populate pom.xml with repository dependencies from Maven. Number 4. Implement factory assembly line principles to support Page Object Model in separate folders. Number 5. Implement advanced execution results collected using extend reports, after which you might implement additional execution information collected using Apache Log4j if necessary. Log4j mostly exists for professional developers. Implement specific web browser options if necessary. It is really optional. Optionally share project code using Jenkins as an open source version and continuous integration control tool, and GitHub as an open source code version control software hosting platform that uses Git to allow team to make separate changes to web project all at the same time if multiple team members are working on the same project. Let's take a look at web elements locators for Selenium Test Automation Framework. A locator primary objective is to identify web elements on the web page to work with them. A locator itself is the argument passed to the find elements methods. The locators are used in Selenium WebDriver test scripts to interact with the web element and perform different set of actions. For example, let's take a look at the extract from Eclipse IDE. I created a web driver instance as a driver, and I'm applying a method fileElements by. For example, on your right side below, you can find element by ID, by name, by CSS selector, by link text, or by XPath, and others. Discover and interact with web elements approach. Web elements locator different types. by CSS ID, for example. By ID and input some web element ID. By name attribute, by name some name. Let's say you found element by some name. By link text, by link text. By partial link text, find element by partial link text in red. By HTML tag name, by tag name, CSS class name, as you can see, as class name, then two popular ones, CSS selector and document object model XPath. For example, saying in advance, Playwright and Cypress actively works with CSS selectors. Let's take a overlook for basic elements locator typical applications. Let's say we have some kind of input text. You can find element by ID, let's say, and clear it. Or you can click on it, or you can click on button. Let's say you found some number 3 CSS by CSS selector. Let's see if a button is enabled. Verify. Or you can find, let's say by XPath, some input text and send keys. Using send keys method, type some text input there. Let's take a brief look at document object model with XPath and CSS. DOM stands for Document Object Model, which is a cross-platform and language-independent interface to treat HTML and XML-based web documents and represents a document with a user-friendly logical tree. It's very hierarchical. There are two types of XPath. Absolute XPath begins from the root of the HTML document and specifies the complete path to the element, and is not flexible and can break if the page structure changes. And relative XPath starts from the specific element and navigates through the DOM hierarchy to locate the desired element. Relative XPath is more reliable. CSS selectors are used within Selenium to target and locate styled HTML elements on page. CSS selector work with you by using patterns to match tags and their attributes such as class or ID. The wide variety of CSS selector available are beneficial because they are shorter than XPath locators and allow a better method to locate an element. CSS selectors are actively applied by Playwright and Cypress. CSS ID attribute, for example, hash ID is used to identify specific elements, and class is used to identify a group of elements with common similarities. Selenium Automation Framework, major languages at current time. There are 3 of them: Java, Python, and C#. You can develop Selenium Automation Framework using any of them in your choice of integrated development environment. Let's take a look at 2 approaches, advanced approaches. Liquid Factory Method Pattern. In object-oriented programming, the Liquid Factory is a creational design pattern that uses factory methods to deal with the problem of creating objects without having to apply their exact class. It works like an assembly line in a factory. That's why it's called like that. In other words, the Liquid Factory is an interface for creating objects in a superclass to allow subclasses to alter the type and behavior of objects to be created. The factory method pattern solution suggests to replace direct object construction calls with a calls to a specific factory method. Instead of calling a constructor, this is done by calling a factory method to create an object. Vectoring methods are specified in an interface and implemented by child classes or implemented in a base class while overridden by derived classes. An advanced approach from liquid factoring method is automation testing page object model. Page object model, or POM, is a design pattern in Selenium that creates an object repository for storing all web elements. POM is popular in test automation, helps enhancing test cases, suites, maintenance, and reducing code duplication efforts. POM object repository consider each web page of an application as a separate class file, containing only corresponding web page elements. It's like different shelves and departments and divisions in a warehouse. The actual executable calling tests apply the POM object repository class methods whenever they need to interact with the web user interface of that specific page, while all changes to support that new elements are located in one place. Advantages of page object model are easy maintenance, efficient code reusability, and reliable readability of automation test scripts. Let's take a look at two typical cases for our page object model approach application. For example, e-commerce, online shopping. There could be separate pages like next. On one page, you filter and select products. You add product to shopping basket. You go to another page, apply where you might apply coupons and sale discounts. Then obviously you proceed to checkout, which is obviously the separate page, checkout page. Then from checkout you proceed to another page where you can add order customer details and pay methods, from where when you apply it and you submit on separate page, on final page, you might receive order completion confirmation and possibly email. All these pages are separate, so web elements for each page supposed to be located in separate folders or subfolders. And let's take a look at financial loan application page object model. On first page, applying customer might verify and authenticate loan applicants or applicant. On another page, on preceding page, a customer might estimate loan affordability and credit history for such applicant. Third page exists for underwriter, for professional underwriter who confirms loan applicants. Then there are usually in financial institution, like in banks, there are two approvers, first and second. First approver might check out loan details and documents, first walkthrough, and superior approver might approve and assign actual loan account. And finally, on the next page, on final page, release financial funds to the applicants, to the loan applicants. That's it. That's a major walkthrough through Selenium automation framework. See you in the next lectures.